This is a solution video of the intermediate puzzle 464, and this was published on February 15th of 2024, and it shows a rectangle, an outer rectangle, including inscribed a regular hexagon over here, and inscribed in that regular hexagon is another rectangle, a green one, and it is given that those two rectangles, the outer and the inner, are similar, so they have the same aspect ratio, which is the ratio between width and height. And the question is what is the green fraction? So the fraction of the area, what is the fraction of the bigger rectangle area that is green? And I'm going to take the approach of ex-follower John Michael, with one proviso that what he and none of the other followers did is to first prove that those lines, that they are parallel. It is not given that they are parallel, but if you look at the puzzle 6.4, which was published a week before this one, you will see that if you have an inscribed rectangle that is tilted, then in that puzzle it shows that the aspect ratio must be 1 to square root of 3. And since here the outer rectangle has the aspect ratio of 2 to square root of 3 instead of, and not 1 to square root of 3, so it is basically twice as high, you already know that the inscribed rectangle cannot be tilted. It must indeed be, this line must be parallel to the upper line. So that's a little addition to that solution. But okay, so we have established then that they are those lines are parallel, the rectangles are parallel, and therefore we can draw the diagonal, and I will show that because they are similar. You can draw the diagonal like this, and from symmetry it is obvious that that diagonal exactly they overlap. So the diagonal of the green one must be on the same line as the diagonal of the outer rectangle. And that comes in handy because, well, what I now will do is divide the figure in 4. I will draw perpendicular bisectors from here to here and from there. So that basically divides the diagram in 4, well, the same, or only rotated rectangles, and I will then concentrate on one of those 4, and if the fraction, that fraction of course is exactly the same as for the total. So I'm going to concentrate on the upper left rectangle and see what's the green fraction in that. Well, from the dimensions of the regular hexagon, you can, for instance, if I put the length A over there, then you know from the hexagon that this one is also A. And that basically is because this is a 60-degree angle. So no, let's put it another way. This, if I complete it like here, then this is an equilateral triangle, OFE, and of course therefore this is divided exactly in 2. So we have A over there and A over there, and down here we have 2A. So the side of that equilateral triangle is 2A. But now you can see that because these are parallel lines, that the triangle OKF is exactly, has twice the dimensions of, and similar to EKG. So because these lines are parallel and the baselines have fraction of 2, it means that all the dimensions have fraction 2. So including the height. So if I extend this line, then we have the height of this triangle. Let's call it 2h for convenience. 2h over there. Then we know, because of the dimensions too, that this part, the height of the smaller triangle AKJ is h, is exactly half. So that's because we have here a and we have here 2a, so we have those dimensions. But that means that this side JK is 3h. So if you then look, obviously these rectangles are also similar, and because they're diagonal overlap. So what we have is that this green area is 2/3 squared of the total, because you make an area, you have to square the length ratios. So what we know is that this is 2/3 squared, which is 4/9 of the large rectangle. And because you have to just apply that 4 times, so that ratio 4/9 stays the same, and therefore the answer to this puzzle, the green fraction, is 4/9.